Good morning, everybody. My name is Zawaydeh. I come from Jordan. Big thanks to, first of all, the Embassy of Czech Republic in Jordan for introducing me to Professor Ladislava. She came to Jordan about a month ago in July. Yeah, a month and a half maybe. We made a nice visits to several universities, and now I'm here. I take this opportunity to present the Jordanian development in renewable energy and some more energies. My background, I teach at the University of Hussein Technical University. I teach energy regulations, policy and economics. I also work in the field. So there are several projects with the World Bank. I work on the smart grid development strategy. We have e-mobility strategy. We have a strategy for long-term, low carbon and climate resilience strategy by 2050. So these are all at different stages of development. I also worked on the development of the ESCOs, energy service companies in Jordan, regulations for licensing of these companies. And I worked on the climate footprint implementation in the environmental impact analysis at the Ministry of Environment. So there's a lot of, let's say, public and private work. And the private work, I do a lot of work in energy management and solar PV project development. So in the past, let's say, 10 years, 12 years, we developed over 200 projects, solar PV. And there is an association of energy engineers. This is in the USA. So there's a lot of volunteering work to enlighten and empower the students and give them more knowledge in energy engineering and energy management. I'm very active with them for the past 15 years. And every year I do more and more. In 2020, I became the president of the association all over the world. So there's a lot of also volunteering work. So this is about me, okay? And I can be reached via LinkedIn anytime you want. So we'll give you a little bit of what's going on in Jordan. We have the conventional, let's say, energies, and we have the renewable energies. A little bit about energy efficiency, and of course we need to talk about the nexus, the Wi-Fi. This is a new term. I don't know if you are using it here or not. Wi-Fi is water, energy, food, environment, nexus. So this is something that is interconnected, and it's good to know. Of course, we live in the Middle East. There is a lot of fossil fuel, but in Jordan, we're not so lucky. But it'll be interesting to just present what we have. Talk about natural gas. We started our natural gas journey in 1998. We signed an agreement with Egypt to establish a pipeline. So who has gas? Egypt has gas. Let's take gas from Egypt. So we built a pipeline. It took us 10 years. So this is like the transmission line for gas. So this goes from the south to all the power generation plants in Jordan. So we produce electricity using gas. And this pipeline was ready in 2011. After 10 years, it was ready. In 2011, they sabotaged the line 17 times. They bombed the line 17 times. So we had to find out a better solution. So we rented a ship. So we rented a ship to store LNG for 10 years. So we rented the ship and put it in the Gulf of Aqaba. This took us about 3 years. In 2014, we went back to using gas in the middle of 2014. And at the same time, we started building our port, LNG port in Akamas. And so after 1.5 years, it was also built. The cost of fuel dropped by 2 billion, 2,000 million in 1 year because of using the gas in electricity production. So, of course, all that depends on international oil prices. But when we shifted from heavy fuel oil to gas, we saved a lot of money. This is the port. It started in 2015. And this is something that is very important that is being investigated, and we have a pilot project which is CHP, combined heat and power. So combined heat and power is basically, instead of buying the electricity, big industries are buying the gas. So you take a pipe, a branch from the main pipeline to your factory, and you buy a CHP, combined heat and power. So instead of just buying the electricity, you buy the gas and produce the electricity and the heat. And when you use the heat in the manufacturing, you increase of course, the efficiency by doubling it. So look at the smile at this guy's face. He's making a lot of money because he installed the first CHP plant in Jordan. So hopefully we have more. So what we need in Jordan, we need a heat law. We don't have a heat law. We have an electricity law. We don't have a heat law. So all the heat is lost in power generation. We have combined cycle, but it's not the same as using the CHP. So we need CHP to be used more often at big facilities like big universities or big complexes, and especially the industrial complexes to use the CHP. So that's why we need to develop our distribution gas network. So we don't have distribution gas network. So we only have the main lines. So that's about gas. When we talk about renewables, we'll give you a little bit about the electricity generation and sample projects. We will also touch upon the manufacturing in Jordan of renewable energies and the future development. And we will talk about what's happening all over the world in extreme weather conditions and how the impact on renewable energy. Of course, the electricity demand is increasing. So we have around 5.3% electricity demand. But I like to point out that we started using renewable energy, solar PV, in 2012. Okay, we are using net metering. I'm not sure if you know what exactly net metering, or you are, because I know that 90% of your solar PV is with storage. But net metering, we don't have storage in Jordan. We have net metering. So basically, the excess electricity is fed to the grid, but I would say 40%, 30%, 40% of all the installed capacities at the rooftops are directly used by the consumer. So the consumer directly used. So even with 1 giga of solar PV installed on grid, we still have increase in demand. So this is you can imagine that without the solar PV, how much the increase in the demand would be. So this is like a very important point. So this is the transmission. Now on the transmission, we have wind and solar. We have 621 megawatts of wind and about 1,958 megawatts of solar PV. So we started in, let's say, the development in 2012, and these big projects, they need 3 to 5 years. So when you talk about big projects, 50, 100 megawatt, you need 3 to 5 years of development. That's why you see the development starting in 2015 and started picking up after that. So right now, the power capacity is 39%. Jordan's 39% of the renewable energy is connected to the distribution and 61% connected to the transmission. So on the distribution, we have about 1,011 megawatts, and the transmission, we have close to 1,500. So the overall capacity of renewable is 2,640 as of August last month. So that's about, we're talking about power. So 37% power capacity in Jordan is renewable, and conventional is 4,447. But just to let you know that we had a peak on the 7th of August this year, and we reached 4,220. So the peak is 4,220. So that's very, very close to what we have. The electricity generation, we are now at 27% renewable energy. So we have from the first one is on the distribution, the DSOs, distribution system operators. We have 3, and the total is 1.5 tera, or 1,577 gigawatt hours. Hydro, very small. We don't have too much hydro. We have wind, we have solar on the transmission, and the total is 5,566 gigawatt hour out of the total capacity of 20.7 terawatt hours. So we have a goal to reach 50% renewable energy by 2030, and hopefully we can reach that and more. So this is the growth. Since 2013 to 23, you see let's say an exponential, but this is all over the world. If you compare to the development of actually the solar PV worldwide, you will see like something similar, exponential growth. But maybe the overall, the global is more steeper than this. So this is the actual distribution, DSOs. So we have 3 companies, distribution companies, North, Middle, and South. JEPCO, IDECO, and EDCO. And the total number of systems is 65,500 systems of solar PV connected to the distribution. And the total of these systems is 1,011 gigawatt. 1,000 megawatt, 1 gigawatt. So we have 1 gigawatt of solar PV connected to distribution networks, which is a lot compared to, to our systems. Of course, this renewable energy helped reduce our CO2 emission. So we reduced the grid emission factor from 690 to now it's 0.4585 kilogram CO2 per kilowatt hour. The sample projects, okay, we start with the solar thermal. Why I like to mention the solar thermal, because the solar thermal reduced the peak load, because you have hot water in a thermally insulated tank whenever you need it. So most of the people, they need hot water when they go to work in the morning or they come back at night. So assume that you don't have solar water heaters, and you want to get your hot water from electricity. There will be a big peak when 3-4 million people want to have a hot water during very short period of time. So what I'm saying, there is a big opportunity in solar thermal, in multifamily, because all of this is the single family domestic. So each family has one system, and this is not very efficient. So we need to develop our systems. The first wind project was installed in 2015, which is the Frila, 117 megawatts, 38 turbines, 3 megawatt each turbine, the rotor diameter 112. These are Vestas. Of course, the Frila is high, so it is about 1,570 meters above sea level. And then we have the expression of interest number 1. This is when we started the development of solar PV, the government said, okay, we will develop one area and put a fence around it and put the substation and do the infrastructure. And this will help the investors in coming and renting the plot of land instead of having random developments everywhere. They concentrated the development in one area, and this helped the developers. So this is the first expression of interest. This here, this is the biggest one. It's 52 megawatts, and it is called Shamsman. So all of this development happened in 2015-16, and it is now commissioned and operational. Then the expression of interest number 2, which is the second round of development, happened in the 2018-2019. Is another 200 megawatts. And this is in the north of Jordan. This picture is for a project in Safawi area in the north of Jordan. Currently, this is the biggest project in Jordan, which is 200 megawatt AC, 247 megawatts DC. This is single trackings, of course, and this is about 65 kilometers away from Amman. It's called Baynuna. And now we have under development a very nice project. It's community solar. Community solar is when you have a group of companies and they form a special purpose vehicle, or they call it a SPV, which is a company, but the aim of this company is to generate energy from solar PV. So each company will have, let's say, 2 megawatts, 3 megawatts maximum, and the government gave them a land about 5 years ago, and they started the development of the project, and now it is under construction. And hopefully, it will be successful. And if this is successful, proves to be successful, we'll have many other smaller projects. Not 135 megawatts, but in the range of 20 megawatts each. If we talk about manufacturing, we have Philadelphia Solar. Of course, Professor Ladislava visited the manufacturing facilities. They currently manufacture PV modules since 2009. And they also have a manufacturing line for the mounting structure. We didn't visit that, but it's not because it's boring. But steel is boring a little bit. And they are also going to expand and go to the US. So they will have a big facility in the US very soon. Also, we have a robotic cleaning. It's a small factory, but right now, I would say all the projects that I'm developing, I try to put robotic cleaning. Why? Because conventional cleaning is expensive, and it will continue to be more expensive in the future. And robotic cleaning allows you to clean more times every year. You have to understand that our environment, there's a lot of dust, okay? So there's an impact of dust. So usually in the contracts and tenders, we ask for 18 times per year, 18 times per year. But when you have the opportunity to clean much more, you will increase the energy generation. So this is an added advantage. You clean more times, it's robotic. So there's a payback of 3-4 years, but the system will continue to work for a long time. Of course, we manufacture the cables, all kinds of cables, and the DC cables. We have one certification. We don't have dual certification, not yet. So TUV, most of the cables are TUV certified, but sometimes, we have projects where they ask for dual certification. The thickness of the layer of shielding will be more, but we don't have that yet, maybe in the future. Of course, we come from a hot area. All the zone in the Middle East is very high quality solar. So cooling is very important. So the technology to use solar cooling is important. We have some pilot projects, but this technology, if you work on research and you like to develop these technologies, I think it will be a very good opportunity to develop it there. So what are the advantages of solar thermal? I mentioned this earlier. 80% of the people live in apartments in Jordan, and these they need to have single-family domestic water heater, whereas they can have a multi-family. So if you use multi-family, you will save on the number of collectors, and you'll save money. But we don't have that technology yet. Also, the financing. The financing is also a problem because Jordan is not a very rich country. The people like, if you ask them for 10, 20 JDs per month, they will pay it. But if you ask them to pay 700 JDs one time, it's a problem. So we always look for financing from the banks and the donor agencies and so on and so forth. Because financing will increase the installation of solar PV or solar water heaters and solar PV, of course. What do we expect in the future in renewable energy? Pumped hydro storage. We will have a pumped hydro storage project, 450 megawatts. I would say in the next 3 to 5 years, more like 5 years because it's a big project. And it will be in Mujib area. In Mujib area, we have a difference in elevation of 700 meters. So we'll have an upper tank and a lower tank, around 3 million cubic meter each. And of course, this project would cost around 500, 600 million. So there's a lot of financing needed for this project. The second thing is the green hydrogen. So the Masdar has already signed an agreement, MOU, with Jordan to develop 2,000 megawatts of green hydrogen. So imagine that we developed, it took us 10 years to develop 2,600 megawatts, and now we will have one project to 2,000 megawatts. Now, what I'm trying to say here is in the future, we will have much bigger projects than the 2,000 megawatts. I expect this year they will announce some more, and next year they will announce some more. So I expect around 5,000 megawatts of development in Jordan by the end of 2030. And this will have a separate grid. It's not connected to the grid, to the current grid. So you need a separate grid. So definitely, Jan, we might have opportunities to develop a grid with Saudi Arabia or whatever, but I think this will be a separate grid for solar plus wind for the green hydrogen projects, around 5,000 megawatts, which is actually equivalent to the the size of the grid in Jordan. But the current grid, it took us 70 years or 80 years to develop. This will be developed in maybe 5 years or less. Of course, we have a solar PV cell manufacturing, and the reason that we are opening a cell manufacturing is basically export to US. So because China and US have a problem, and so we have the US market, and that's why we are increasing the percentage of locally manufactured products in Jordan, so open up the US markets. We have a solar, we have a water desalination project, 300 million cubic meter. This is already awarded, and now they are selecting the subcontractors. So I think by the beginning of 2024, we will start construction in 6 months. So this is a 300 million cubic meter. Its energy, 50% of its energy will be from renewable energy. So they need to install 240 megawatts of solar PV, somewhere in the south, of course. And we have storage. Now this is storage strategy. Jordan needs storage for load shifting, because all of this renewable energy, solar PV, is being produced during the day. So now we are creating the duck curve. So now more and more energy during the day, it will eat up from, so we need to shut down our conventional thermal power plants during the day, and that will create problems. So that's why we need a strategy for storage. Now, we have pilot projects on distribution, we have pilot project on transmission, but we still don't have the strategy issued yet. But we estimate that we need around 120 megawatts, and that's very, very small number. So I think the Czech regulations, because Professor Ladislava gave us a presentation and said that 90% of the systems installed here has storage. I think there's a lot of, let's say, knowledge and experience that can be shared between the two countries in storage. Electrification of transportation. This is happening globally because of the use of, because of technology. You have to follow technology. And China is leading the EV revolution like it led the solar PV revolution. So during the next 10 years, we will see a lot of EVs. Actually, more than 50% of the cars sold, the new cars sold in Jordan, are electrical. And without a strategy, 50%. So if you look at the world top countries, they have a strategy for 50% EVs by 2030 or 2035. Now Jordan is achieving 50% EVs in 2023 without a strategy. Now we are working on a strategy, but what I'm trying to say is that the development in transportation is very rapidly growing. And it is economical. Because the cost of fuel here, because we import fuel, cost of fuel for transportation is very high. And now, because of availability of Chinese EVs, they are cheap and they run on electricity, we save a lot of money. So, what are the next steps? Next steps is to reach 50% renewable energy in the electricity generation. This is something that is going to happen. It's already happening because we reached the maximum peak 70%, but on average we are at 29 now, maybe let's say 30%. But our average will become 50% by 2030. I think we will achieve that much earlier. But now let's say 2030. The pumped hydro storage. We need the pumped hydro storage for the duck curve and the load shifting. So this is something that our grid needs, and we need regulations for the storage. I know there are a lot of people working on that, but it's still not issued yet. The technology of storage, I would say, started last year in 2022 when the manufacturers for solar PV like Jinko, Trina and Longi, they all started offering storage. So I thought 2022 will be like a transformation year in the storage, but it didn't happen. I think the prices are still high, and the quantity available in the market is low. But we need regulations. Without regulations for the storage, the DSOs, distribution system operators, will not allow storage. So it has to be more, let's say, more technically studied. Now we started the time of use. The time of use so basically the tariff change according to the time of the day. So now we have 3 zones, A, B, C, from 6 a.m. to 2 p.m., where you have the sun peak hours. The electricity cost is low. So this will work as a driver for people to use electricity during these hours. Of course, then you have the B zone and the C. The C zone is actually where you have the peak at night, when all the people are there between 6 p.m. and 10 p.m. So we need also to increase the community solar. Community solar is very noble idea, where if you are a group of hotels or a group of hospitals or a group of similar industry working together, then you do a project to serve yourself. I know that is very popular here in Europe, and maybe it's successful. I'm not sure how successful it is in Czech, but we're working on it. Also, we are establishing a cell factory, and now we are experiencing the important thing, which is climate, and we don't know what's happening next, and all these projects that we are developing might suffer from climate and get destroyed overnight. Who knows? Energy efficiency. Energy efficiency, why we need to talk about energy efficiency? Because it's important, because you are using technology. So we have initiatives in the 3 big sectors, so transportation, industry, and buildings. So we need to start applying energy efficiency in these big sectors. So, which one first? Transportation. So what are we doing in transportation? First, we allowed the EVs. So we allowed the EVs to start entering the market in 2013, and they were free from customs and sales tax for 5 years. So you don't pay anything, just, but you have to remember that they were expensive 10 years ago, but now they are cheaper. So in 2019, we increased the customs 10 to 15%, which is still cheap based on the battery size. We also developed the public transportation. It's something called the BRT, Rapid Bus Transfer. In Jordan, we don't have a lot of public transportation here, like in Czech. You have beautiful public transportation. You have the metro, you have the trolleys, but we are still young in that division. But the BRT proved to be successful, so we're saving a lot of energy there. We are also building an EV manufacturing. So we are expecting to have 150,000 EVs manufactured in Jordan by the end of this year. This is in partnership with China. We are expanding the BRT, so we'll have another round of development. And we are also thinking of a big project, which is a dry port from the capital to the port of Aqaba, and that will cost around 3 billion US or 2.1 billion JD. This graph shows the development of EVs in Jordan. Now, we are in 2023, and up to August, in 8 months, already sold 25,500 cars, and it's exponential. It's exponentially growing. And this is, this is the owner of the new EV factory in Jordan. They signed an agreement with a Chinese company. So let's see what happens by the end of the year. And this is the BRT, bus rapid transfer. One segment, very simple. They are moving around 1 million to 800,000 people a month, which is very successful. Hopefully we'll have another round of another development. So the green development in Jordan in the transportation or EVs, this requires chargers. The type of chargers are public or private, or it can be at the gas stations. So basically, we need infrastructure development. And this infrastructure development costs money. You need cables, you need transformers, you need substations. So basically, we are expanding our distribution network. Nothing on the transmission, but the transmission supplies the distribution. So whatever demand the distribution needs, it has to come from the transmission. So the transmission needs to expand their generation capabilities. Of course, the time of use, it's changing the people behavior will require a lot of change in the tariff. But right now, the tariff is not too much different. So they need a lot. They need to change the tariff in a much better way. In the buildings, we talked about transportation. We talk about buildings. In the buildings, we had a incentive program to build sustainable buildings. So basically, if you have a nice building, they give you extra area to abide by the sustainability rating system, and you can get, let's say, a certain percentage areas. We also distributed the government distributed free LEDs, of course, to save money for the government, and we started testing the quality for all imported LED washing machines, air conditioning machines, fridges, all the big equipment that are consuming a lot of electricity. We make sure that they are up to standards. And we implemented the energy label since 2017 and installed 32,000 solar water heaters in 1 year. But unfortunately, we could not repeat the same success in following years. So this is the first building that is dually certified. I was the consultant on this building. We achieved LEED Platinum and the Jordanian rating system, Jordan Green Building Guide. So, but we have less than, I would say, 30 buildings in 10 years. So this is very not successful. As far as energy efficiency development or regulations, we have the bylaw number 73. So bylaw 73 is all about energy efficiency. And they talk about energy auditing and licensing. We have also adopted the British energy auditing specification of standards and used it as Jordanian standards. And now we're trying to do the ESCO licensing, the energy service company licensing. So if you look at the sector in Jordan, we have the regulations, but we are not implementing them. We don't have enforcement. So it's one thing to issue regulations, another thing to implement them. So you need a lot of people. So it's like having the law and you have the police force. You have the law, but you don't have police force. How are you going to apply the law? So the same thing in energy. You have energy efficiency, but you don't have people to apply it. Then you have auditing. The auditing, sometimes some people apply, some people don't apply. And the design. The design, we have a lot of engineering design offices, so design is very good. The performance contracting mean is that I would convince somebody of an energy conservation measure, tell them, okay, I will change your old HVAC equipment, I will pay for them, and you pay me from the savings. It's a very good deal. He will do nothing. I will take all the responsibility, but he has to pay me from the savings. So this is the performance contracting, and we try to do this, but it's not very successful. But it's only successful in the air conditioning industry for the big companies. So hotels, they do that. Hospitals, they can do that. The financing of energy efficiency projects, very shallow. We have few, not too much. Procurement, of course, we buy all kinds of equipment. We are very good execution. We have very good contractors, no worries. Third-party monitoring and verification, we have an issue there. We don't have a lot of people who are experts in M&V. In training, we have a lot of people who can do training, and operation maintenance, we also have few, not a lot. So this ESCO modeling that we are trying to develop in Jordan, which is developed in the in markets like US, China, India, and Gulf, probably not in the Europe, but so basically we have an energy service company that will do the energy auditing and the project development and the execution. If there is a design, they will contact, if there is a design, they will contact the engineering office. If there is a big need for construction, they will contact a licensed contractor. Now this ESCO needs to take money from the bank. And now if the ESCO is small, the bank can lend the owner the money, okay? So the loan can go to the owner. The ESCO and the owner will have an agreement. The ESCO will do the project auditing, development, and execution. And the ESCO will get paid from the money that is taken from the bank, from the savings, from the reduced savings. And then you need a third party to do monitoring and verification. We have an regulator, EMRC. They are they supervisors. They are oversee the energy licensing, ESCO licensing, the upgrades, and the renewal. So this model we are trying to develop in Jordan in big way, but small steps. The thing that you have to look at in big vision is the energy sector is linked to the economy and the employment. The energy sector, once you do these performance contracting projects, you are going to pay sales tax and customs tax on all the electrical equipment that you bring. Let's say that you change the chillers and air conditioning for 5,000 companies or 1,000 company per year. And those, and the cost is 10 million. In the 10 million, you're going to pay about 30% customs and 16% sales tax. This will come to around 8 million JDs. And you are going to employ a lot of people here, and these people will take salaries, and they will educate their kids, and they will also pay taxes. So this is all a big cycle interlinked. So the driver for this cycle is energy auditing. Energy auditing costs money. Not a lot of people. It's like going to the doctor every year and doing checkup. You need to pay for your doctor fees in order to make sure that you are performing well. So there is a lot of benefit to doing these things. If we're talking about industry, last year we started the Green Award in the industry. So basically we targeted 5 types of industries and applied these criteria: energy management, water management, waste management, knowledge, documentation, internal processes, technology, investment, safety and planning and measurement and verification. And we had winners. So basically, next year we will have more than 5 sectors. We'll apply it to 10 sectors and next year, and after that we'll apply it for the whole industry. The WEFE, energy, water, food, environment nexus. So we have a pilot project in Aqaba, and that project is by a Norwegian company. So basically, they are taking the water from the sea, doing desalination, using the solar, and then doing air conditioning for the glass houses, and planting around 130 tons of food and shipping it to Norway. And this is a very successful project. And of course, you can use the same ideas to ensure food safety and so on and so forth. The extreme weather conditions. This is very recent, by the way. This is on the 28th, 29th of May. We had this size hail. So of course, this size hail is bigger than the standard hail size for PV and whatever. So it destroyed solar water heaters. It also destroyed solar PV panels, and it's destroyed cars. So basically, what are we going to do as professionals in the future? We have to design for all of these things to make sure that we don't have these extreme weather conditions, because these extreme weather conditions will continue to happen on bigger scale. This is definitely will happen. Another thing that happened last year, 22, in January, we had 40 centimeters of snow in 12 hours with extreme wind. 160 poles were destroyed within 10 hours. You can imagine the shutdowns all over the city. It took us 5 days, 6 days to restore all the electricity. But the thing is that we are going to experience more and more. So you need to make sure that your infrastructure is better. So throughout the past year, we started changing the infrastructure without the need for being destroyed. So you make sure that your infrastructure condition is above a certain level. So it's very old, more than 50, 60 years old. Now it's the time to change it and make it better. What are you going to do about flooding? I'm not sure. Have you been to there, Professor Latislava, to the downtown? So this is the downtown. It is in the middle of the downtown, and we have a Roman amphitheater. And because this is in downtown, all the water will go down, and it gets filled. And of course, all the merchants around that area, they lose money because all their products are destroyed. So the city, the municipality has to compensate everybody. They spend 10 million compensation. Destruction happened in a few hours. So, and then we have to increase our intakes and build more culverts and so on and so forth. So these extreme weather conditions will continue to increase in the future, and we have to be smart in designing our infrastructure. Solar PV. Because of the, I think it's because of the error of one contractor. They were not placing the PV correctly. Of course, this is single axis tracking. They had a big storm, and 50 megawatts were destroyed. It flew everywhere. So, needless to say, this contractor was bankrupt. But you have to adopt a very, very strong, stringent procedures at site to make sure that these things don't happen, even if your wind velocities are correct. Now, fossil fuel. What do we have in fossil fuel? We don't have much, of course. Now, the oil shale, we have a lot of oil shale, So we built a plant. Now we have a 470 megawatts of electricity generated from oil shale. So this is with the help of Chinese money. It's about 2,000 million. It will operate for a long, long time. But we have a problem. Is the cost of electricity is high. So because the cost of electricity is high, we have to negotiate with the Chinese. Chinese don't want to negotiate, so now we go to court. So now the project is on hold until we solve this. So big issue. But it's 2.1 billion US. So these are basically three companies. One is power generation, and one is the maintenance, and the third one is the extraction. And we have gas. Where is the gas? You see, Jordan is here. This Amman is here, Jordan, and gas is here at the edge of, at the border with Iraq. This is Iraq here. We have a small plant, 60 megawatts, and they want to develop it more. So we have 2 by 30 megawatts. They want to develop it more. We'll see what happens there. And now we have oil. 1,500 barrels of oil per day from Hamza. It's nothing actually, but it's good. It's a good start. And this is the. I hope you enjoyed my small presentation. If you have any questions, please let me know. I am ready to answer now or in the future at your service. Yes, sir.
I have one question about you was talking about in the beginning of your presentation about the generated heat we can use. So what about the transfer of heat from one place to another? Usually heat is transferred by conduction, convection or radiation, but there will be huge heat losses. So if I want to transfer, let's say 2 to 3 kilometer heat from one place where it is generated to another place, what method will you recommend and how will we keep the losses in control?
Hot water, thermally insulated pipes, but we're talking about the same plant, not 3 kilometers, maybe.
Can you run in the same place?
Yes, yes.
No, we cannot move it, okay.
Yes. Yes. Yes.
You have shown this hydro pumping option that you start with. How many potentially places like this you have here?
We studied 6. We have 3 good potential.
Is it north or is it distributed?
They are all located at dams. Yeah, so they're not too far apart. I mean, within 200 kilometers, not too far apart.
Then you have to think about transmission.
Yes, yes, yeah. One of them is already connected to the transmission, is where we have the hydropower. I showed you that we have we have some hydropower here. See, this hydropower location is already connected to the transmission, and this is one potential site. And we are going to also develop our hydro, another 18 megawatts at the same location, maybe in the next 5 years. But for pumped hydro storage, it will be at another location, the one I told you about.
Because this pumped hydro storage looks like a good option for you as a complementary to solar.
Yes, yes.
That's why I'm asking. And you said that it's critical that you don't find companies which would make it.
Yes.
Which I don't agree, because we are in this business
That's why you have
years. And you can find these projects in Europe, in Alps, in Norway, in Malta, in Japan, everywhere. So it exists and it's very efficient.
Yeah.
Because you can pump, produce at the same time with the technology which is now available. So it's extremely flexible.
Yeah.
And it's really bulk power.
Yes.
If you have enough water.
Yes, yes.
I see you have, but not all of us.
Yeah.
You have enough water if you don't like it.
Yeah. This project will have two reservoirs, upper and middle, and solely dedicated for this process. So, yes, it's not connected to the dam water. This is separate.
You don't find a company which will make for you turnkey project. For example, we are making only electronics, power electronics, but that's the key, the brain. But then someone is doing dams, someone is doing turbines. You have to have some smart integration.
Yes.
Then you can do what you want, because it is all available, all the technologies.
I think in Jordan we learned the lesson that we don't care about the let's say the process. We only buy the electricity.
But it's difficult in such project because this is special projects.
Yes.
Each and every site is a special project.
Yeah.
It's not on shelf.
Yes. Yeah. That's what we do in solar and wind. We don't care about the project. What we do in the project, we just buy the electricity. The whole responsibility is on the developer. So we need the developer to do the whole thing, and we buy from him the electricity. I think because if we need to develop it from scratch, then we need a lot of know-how. So building this know-how would take years and years. Imagine you want to send 50 PhDs and so many disciplines, and it's a long thing. So it's a business basically, and then you're buying electricity.
But this know-how exists, I can tell you. But the problem is that you have to have stable government offices which know what they want. Yeah. For example, Saudi Arabia, Egypt, HVDC line took 10 years to get into agreement.
Yeah.
And we were, for example, tendering this project several times. And after 10 years it happened.
Yeah.
So it was actually a problem on the side of government. Of course, it's cross-border, so it's not that easy like if you do it in the country. But still, it takes years. And government changes or king dies and then everything goes down. Yeah. So, but it's possible to do such a project in 5 years.
Yeah. We have developed very good experience in renewable energy. Now we have very good PPAs, power purchase agreements. So our power purchase agreements were developed by the best consultants in the world. Now it takes us like 1 month to finish a project. To make the agreements in 10 years that you talked about, it takes us 1 month to finish between the two parties, because we have very strong power purchase agreements supported by the government. So we are very strong in this way. So we can finish this project in a way that is focused on the outcome, not focused on the process. If we want to focus on the process and divide the project into building the reservoir, purchasing the pumps, operating, and blah, 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 it will take us 15 years. We don't know it. We don't want that. We just want to focus on the end product. We want one company to build, operate, and then transfer after, and maybe not transfer. We keep continuing the operation because we want to focus on the product.
Yeah, this everyone wants,
Yeah.
But you have companies for for generation of energy, but then you have TSOs, transmission system operators. They are different companies. So you cannot get it all in one.
We have one TSO. One TSO is responsible for the all.
Local, your own.
Yes, our local.
But you need someone who comes with some know-how, which you need.
No problem in the with. Yeah.
Like your neighboring countries.
Yeah.
For example, they have tons of gas. They don't know what to do with it, so they have to burn it at home. So they produce power plants, aluminum smelters, everything. Yeah. So and they cannot do it on their own. They have to purchase it from outside.
Yeah, Saudi Arabia is different. Yeah, they are different. They have a different system, completely different system. a very rich country. They can do whatever they want. But us, we have to be a little bit smarter and wiser because we have limited resources. Yeah. But I think they will tender this as a BOT, build, own, transfer, build, operate, transfer, BOT, within the next maybe 1 year, maybe. This will happen, yani. But we focus on the result, on the kilowatt hour. How much is purchased, and the TSO. They might have a in-house. They will develop their in-house capabilities, and they might have a consultant for a few years until they build their capacity. But our TSO is good. Yeah. Yes, sir.
So can you say more about this? You say you focus only on buying the electricity. Like, what is the condition? So what is the, let's say, you buy for the market price, or you give some better condition, or because you also mentioned this power purchase agreement, I'm not so much familiar with this. So yeah. Can you explain?
Yes.
A little bit?
Yeah, I will tell you the whole story. So the whole story goes like this. In 2010, the cost of kilowatt hour, producing kilowatt hour in Jordan, was 0.15 Jordanian cent, or let's say 22 US cent, cost of producing electricity in Jordan. So now comes the solar, and now comes the wind, renewable energy. So kilowatt hour from wind was 12 US cent, and kilowatt hour from solar was 17 US cent. So these are very cheap compared to the 22. So the government in 2011 started with the feed-in tariff, fixed. So it said feed-in tariff. So I buy the electricity at this rate, okay? So they fixed the rate of purchasing the power. Good? Yes. Clear. So the first round of 200 megawatts and first wind projects that happened in around 2012 were with the type of contract feed-in tariff fixed for 20 years. Clear? Beautiful. Then what happened is the technology started evolving and the prices going down. So why do you want to fix the feed-in tariff? So we canceled and we went to competitive bidding. So the government said, I will buy electricity at the cheapest rate. I don't care. You give me at the cheapest rate and the highest quality. So the prices dropped from 17 to 7 US cent, or less than 7 US cent. Actually 5.6 US cent. And so the second round of 200 megawatts were with power purchase agreements, competitive bidding at 5.6 US cent per kilowatt hour for 20 years. And we have a third one where the price of competitive bidding was at 2.55 US cent per kilowatt hour. So now the cheapest or the lowest price, lowest average price at 2.55 US cent per kilowatt hour, that was in 2018. So from 2018 until now, the past 5 years, we didn't have competitive bidding yet, but hopefully soon on the big hydrogen projects. Yep. The power purchase agreement is an agreement between two parties, the government and the power producer. And this agreement has to be balance the risk. So the government needs to have the money to pay for the investor, because the investor is going to come and put a lot of money, billions sometimes, to generate electricity. So the government, the investor needs guarantees. So these power purchase agreements, they maintain the risk, they levelize the risk, they level the risk between the two parties. So both are in agreement.
So if I can ask, it means that this 2.55 or
yes,
let's say 6 US dollar cents, this is the price for which they will buy the electricity.
Yes.
Does it mean that the government will buy all the electricity, or if there is, for example, not demand?
100%. No. They have to buy all the electricity. All the electricity that the investor is producing. 100%. Buy or take. If they don't buy, they have to pay money. Even if they don't take, they have to pay. That's why by law, the government has to use all the renewable energy. Because this is the law, renewable energy law. You have to use the renewable energy first. Yes. But it's something that can be developed here. Yes, sir.
What is the influence to final price of electricity if you increase the renewable sources? Because it's not just only price for the electricity, it's price for storage and for transmission, etc. So what is influence to the final price of electricity in your country via increasing this new?
This is a very smart question, very complicated to answer. Right now, I can tell you what I know. The price, average price right now is around 7 or let's say 10 US cent for the 10 US cent. But this price is we are also experiencing shutdowns. We are asking also the renewable energy projects to curtail, to shut down their plants, because we have a lot of solar PV. So there are additional expenses. So these additional expenses, they're costing us maybe 250, 300 million per year. We are shutting down renewable energy, we are shutting down the conventional sometimes, so because we don't have storage. So imagine, every year we are paying 250, 300 million, so you can do this plant very fast, you can save a lot of money. I don't think there is anybody who can predict what is the average, let's say, kilowatt hour will be in the next few years because of the fluctuation in international oil prices. You might have a war somewhere, and if it's close to the oil producing countries, then everything will be different. But let's assume that everything will continue the same at the 80. So we will stay at 40. Right now, we are at 10 US cent plus additional cost. I would say 14 US cent is the cost of kilowatt hour. Once we have storage, hopefully this will go down. Once we have storage. And I hope that we can develop our storage strategy to allow the private sector to go into the market. If the private sector goes in, controlled by the public sector, by the DSOs and TSOs, I think we will have success stories. But it's all new area, so difficult to judge what will happen.
And the second question is about the safety. So do you mean the whole power system will be safe in this portion of renewable?
It is safe, no problem. We are at, we already have 70% renewable. It is holding up, no problem. At one point in time, we had 70% renewable.
You are not worried about some blackouts?
we are worried about? Blackouts. Yeah, we had a blackout because I'm not sure what was the reason, the exact reason, but yes, we had blackout. I think 2.5 years ago, we had one blackout. Yes, yeah.
I'm speaking because we have some experience with not blackouts, but with the energy crisis here in Czech Republic and increasing the prices of electricity very rapidly.
Yeah.
And the reason is a little bit different, but I think this portion of renewable needs some good storage for connection to other network.
But if they run maybe too much in island mode, then you don't have blackout, because there is nothing to go black.
Yeah.
It depends how big is the grid and how complex. Yeah? This would be my another question. What are your plans for energy grid to combine all those things? If you have north, middle and south, and then you have to distribute, you need to invest into grid, which is somehow invisible to investors. It's just cost.
The connecting with the neighboring countries is a very good idea.
Not even inside.
Ah, yes.
Already.
We
Because this is about blackouts. Yeah? If you want to avoid blackouts, you have to strengthen your grid. It's grid resilience. It's a big topic now.
we have a separate grid for the renewable energy. We have from the south to the north. From the south, where we have the renewable energy, the wind and solar, to the demand center in the north. So the demand center is in 3 cities, in Amman, Irbid, and Zarqa, which is in the north, let's say. Renewable energy is produced in the south. And we have a transition line. We call it the green corridor.
What are the parameters of such lines? It's HVAC.
Yeah, 400 kV. It's not very high. It's not high voltage. No. It's high voltage, but not too high. 400. Yes, sir.
My question is, who made this grid? Is it like or
This was the
transmission line operator?
yeah. That was the requirement of the TSO.
And is it private or is it?
No. This is owned by the TSO.
And the TSO is private?
No, it's government, 100%.
Government. So it's like here.
Yes.
Usually, when I talk with our TSO, they say, we are not going to do anything. We only have to take care of what, like, they don't want to go to some projects. Like, actually, I think our TSO should not earn money.
Yeah.
Correct, but,
The TSO is 100% owned by the government. The distribution system operators are private. The distribution system operators are private. A long time ago, like 20 years ago, all of this was one company, but they divided it to privatize and blah, blah, blah. What will happen in the future, I think we might have some more privatization because now the TSO is also buying the LNG. So we might have some separate company buying the LNG. But the system operator will stay with the government.
So we have one TSO and
One TSO. Yes.
So we have state in the state because it's power, it's sort of one, it's classic. It's like state grid of China.
State in the state.
State in the state, yeah.
State in the state. Good. So good.
That's why you privatize to have more players.
No, it's not state in the state. No, I don't think so.
so maybe for me to understand. So this power purchase agreement.
Yes.
Is between who exactly?
Between the two parties, the producer and the buyer.
And the buyer is who?
The TSO.
TSO.
Yes.
The buyer.
The TSO buys all the generated electricity. No, the investors are private. Yeah, the investors are private. We have very, very small, I think two-thirds, more than two-thirds of the power generation is private. We have small. The old ones are with the state. And sometimes we have donations, like 50 megawatts and small things, and they are also with the state. 5, 10, something like this. But the big ones are private. For example, 247 megawatts, the 135, they are all private. All the wind, well, most of the wind. Only one project in the wind is 80 megawatts is with the donation, I think, from one Arab country, maybe Kuwait, I think. You have to understand that the government is poor. For example, the water sector, water is very cheap, but the water sector consumes a lot of energy. 50% of the energy is consumed by the water sector. So sometimes they do a project to support the water sector, but this project is owned and operated by the government. The 15% of electricity is needed for the water sector, and this is a lot of energy. So we're moving towards also renewable energy in the water sector. So instead of giving money, they give renewable energy project to the government to support the water sector, for example. We have maybe 2 or 3 projects like that. Yes, please.
I have a special question. We have in the Czech Republic very small but important company. The name is operator of the market. This operator prepared every day plan not only but this cooperation with every company who would like tomorrow to go to the system. Especially in summer, sometimes a problem with solars, because sometimes today they say 20 gigawatt hours, and the day after it's the different situation. And the market operator, if it is over, could say, you have stopped and keep what you said yesterday, or you have paid the special support of hydro or coal companies. Do you have something like that?
No, we don't have a separate market operator for energy and the energy prices, no. This idea has been discussed a few times. Maybe in the next 5-10 years, maybe we see it, but I doubt. It's very complicated. You are a mature market here, and you're stable, and we're still growing, and we have so many parameters happening, so many, and the geopolitics. No, I don't think it's not over electricity, because when you have a lot of renewable energy, you have to use it, but it's available there, but you cannot control it. It's intermittent. So we are shutting down the conventional, okay? But let's say if you are in winter, you don't have solar, you have to use conventional. And the conventional is really very critical, because we reach 4220 and we have maximum 4447. So it's critical. So we don't have. It's how you look at it. But we need to develop the system in a better way to have more renewables. So if we have more storage, I would say maybe in 5 years, if we have more storage, maybe we are stable. But I think we're growing at a very sharp rate with the EV, electric vehicle in uptake. I think it is underestimated. The EV are underestimating. I think we will need much more electricity, maybe 25% more electricity within the next 5 years. It all depends on the uptake of e-mobility, and now we didn't start the e-buses. Once we start the e-buses, it's a different ball game. So the electricity system will continue to grow, yeah, and the solar PV will continue to be cheaper, and it will be more lucrative to install solar. But solar will provide, without storage, will create a problem. So we need solar plus storage and continuous growth. Yeah. This is what will happen, I think. Yes. We have regional interconnectivity, just to let Ian. We have connectivity with Palestine, and we're selling to Palestine. We have connectivity with Syria, but this is geopolitics controls that. When Trump was president, we were going very fast to sell to Lebanon. When Biden came, he started the war with Russia, and everything stopped. So the connectivity with the north is dead, I would say. Now we're going towards Iraq, and hopefully we can sell Iraqis. So we take from Iraq oil and we sell them electricity. And then there is Saudi Arabia. We're trying to do a Saudi Arabia connection. We'll see what happens. And when we have connectivity with Egypt, undersea cable, and we depend on that for stability, and we are going to increase the size from 500 megawatts to 1,000 megawatts soon. Yes.
We have the same, and sometimes it works like how you said.
Yes.
Yes.
Yes, yes. It will happen. Maybe another 50 years. We'll see. Yeah, it's a good idea, but the technology, you know, how much drop in prices happened in the past 10 years, and it will continue. Now, in solar, we are, the world is installing around 350 gigawatt globally every year, but they want to reach 1 tera every year within 5 years. So by 2030, you will have 1 tera. Imagine 1 tera every year. That is huge. The prices will go down. The prices will go down. The US has decided to fund projects to reduce the prices by 60% by 2030. This is the Department of Energy in the US.
There's also a question regarding who is driving in your country to build the new cell manufacturing? It is
Public sector.
Public sector.
Mayum manufacturing. That's all.
So you module, but you also
Yes.
cell.
Yes. They will build the cell factory.
Yeah, and is it
Yes.
private investment?
Yes. This is the private sector.
Do they get some advantages from government? Like
No, they don't get anything from the government. No. They want to build the cell factory, as I told you, to increase the percentage of local production to ship to the US.
because now all the investors are building factories in the US, as you said. You know?
Yes. We are building both. We are building a factory in the US, and we are building cell factory in Jordan.
Okay.
Yes.
So you are subsidizing the one in Jordan because you will maybe get some support in the US.
Exactly. Because there in the US you have the IRA. They are spending $371 billion by 2030. For example, if you are going to install at your house, maybe you get like 40–50% off. And the same thing for the local manufacturing. They get money. So it becomes cheaper for them. They can have a very fast payback period for the plant. So if you invest like $200–300 million, you can have a fast return on investment, because you're getting money from the government.
So maybe one last question.
Ask them, no problem.
What is the production of solar in, let's say, in December in Jordan compared to in June? Because in our country, it's maybe 20 times lower in December compared to June. And I think, according to some data I have, it should be maybe half in December compared to June.
40%, I would say.
40%?
Yes.
But it's still very relatively good compared to
Yes.
our 5%.
Yeah, but
40%.
on average,
Yeah.
in Jordan, you get 4.3 kilowatt hour per kilowatt peak per year.
Yes.
4.3. So you multiply 4.3 by 365, you get every kilowatt peak, you get 1,560 kilowatt hour. Every one per day. Okay? This is the average. But the maximum is 8.1. So if you go south, the further you go south in Jordan, the higher quality solar. So you produce more. That's why investors, they go and put their plants in the south, so they produce more energy. Okay?
Yes, sure, but for me, more fundamental question is the difference between winter and summer. Yeah, so you say in winter you have 40% compared to summer.
In the hilly areas, but in the south, I'm not sure. I have to make sure. But I checked in the hilly areas. It's where we have. In Jordan, we have around 300 days of sun without clouds. 300 out of 365. But in the south, you get much more. You get maybe... Yes. You can... 1 kilowatt peak, single axis, can give you 2.8.
What I'm asking for is maybe more dependent on how often you clean the dust from the solar cells. Yes, I understood. This is serious problem.
The big projects, they have the solar brush, the one car with driver, and the brush 3 meters or 6 meter brush, they keep continuously cleaning. And this is every evening. Cleaning is done in the evening. When the sun sets, they start cleaning. All the plants.
It's extra cost. It's extra cost.
Yeah. Extra cost? No. Because you are making a lot of money. No problem. There is a lot of sun there. You generate a lot of sun. You generate a lot of electricity from the sun. 1 kilowatt peak producing 2,800 kilowatt hour per year in the single axis. It's amazing. 1 kilowatt single axis can produce 2,850 kilowatt hour per year. Jordan is amazing in solar. Yes. That's why the investors come and invest in Jordan in solar, because they have a very good return on investment. Yeah. Hopefully this hydrogen projects, they will happen soon, then you can be all part of it. Come and see. Develop the grids, develop new research, and be part of this.
So how big is your hydrogen plant?
The hydrogen, they're talking about 2,000 megawatts, but I think every year now they will increase it, I would say 5,000. 5 gigawatts, yes. In the south, yes. Yes. It's a different grid. It's not connected to the... Yes. Yeah. The main idea is to use it as fuel and to export it. They will use it in the industry, and they will also export it. We'll see. Thank you very much.